Hi there, and welcome to my channel. In this question, we are given that a company designs spinning toys using the family of functions y equals c times x times the square root of 4 minus x squared, where c is a positive constant. And the figure above shows the region in the first quadrant bounded by the x-axis and the graph of the function for some c. And each spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. And both x and y are measured in inches. And so the first question is find the area of the region in the first quadrant bounded by the x-axis and the graph of this function for c equals 6. And so what we need to find here is we need to find this area under the curve. And note that in order to do that, we need to have these 2 points, x0 equals 0 and x1 we need to find. And this function is y, which is a function of x, which is given to us, f of x. And then this area, in the usual fashion, is equal to the area under the curve from x0 to x1, f of x dx. So let's find point x1 first. And so that is when y equals 0, or in other words, plugging in c equals 6, 6x square root of 4 minus x squared equals 0. And this is equal to 0 when either x equals 0 or the expression under the square root 4 minus x squared is equal to 0. Solving for x here, x squared equals 4, and x equals 2 because we only need the positive solution. It's x1 is in the first quadrant. So the answers here are x0 equals 0 and x1 is equal to 2. And so then the area in our specific case is equal to the integral from 0 to 2 of 6x square root of 4 minus x squared dx. And how can we solve this integral? We see that maybe a natural u substitution here is u equals 4 minus x squared, the expression under the square root. And in that case, du is equal to negative 2x dx. And solving for dx gives us du over 2x with a negative sign. And so plugging in, before we plug in the values, we need to find the limits of integration, which is for x equals 0, u equals 4 minus 0 squared, which is equal to 4. And then the upper bound is for x equals 2, u equals 4 minus 2 squared, which is equal to 0. So the limits of integration, the lower bound is 4 and the upper bound is 0. So then that means that this integral is equal to the integral from 4 to 0, 6x, instead of the square root 4 minus x squared, we plug in square root of u, and then instead of dx, we plug in this expression, negative du over 2x. And we see that nicely x cancels out here. We get, and then 6 and 2 both divisible by 2. So we get this is equal to negative 3 integral from 4 to 0 of square root of u d, which is equal to, we can change the order of integration and get rid of negative sign, which is equal to 3 integral from 0 to 4. And rewrite u as u to the power of 1/2 d u, because square root is just u to the power of 1/2. And this is equal to, taking the integral of the power function 3 times 2 over 3 u to the power 3 over 2, and plug in the values 0 and 4. This is equal to 3 and 3 cancels out, and then we plug in the values 4 here. It's 2 times 4 to the power 3 over 2, minus 2 times 0 to the power 3 over 2. Second term is 0, and the first term is 2 times 8, which is 16. So the answer here is 16. Let's move on to question B. In this question, we are given that the derivative of this function, dy over dx, is given by the function c times 4 minus 2x squared divided by the square root of 4 minus x squared. And for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. And we need to find the value of c for this spinning toy. And so first note that on this graph here, this is approximately where this largest cross-sectional circular slice is, the derivative of the function has to be 0. So dy over dx has to be 0 at that point. So that might help us to find this x such that at that point the derivative is 0. Let's do that. Let's find that x. And so dy over dx, which is equal to c times 4 minus 2x squared over the square root of 4 minus x squared equal to 0. And so this is equal to 0 when the numerator is 0, which is 4 minus 2x squared equal to 0, which is 2x squared equals 4, dividing by 2 and taking the square root gives us x equals square root of 2. And we only need positive value here. So x equal to square root of 2, which then means that we get the plugging in back into y equals c times x times the square root of 4 minus x squared. We need to find, we are given that y is equal to 1.2. So let's plug in x equals square root of 2 in here and find c, solve for c. So 1.2 is equal to c times square root of 2 times square root of 4 minus square root of 2 squared, which is equal to c times square root of 2 times actually again another square root of 2, which gives us 2c. So it turns out to be pretty simple that c is equal to 0.6. So the answer here is c equals 0.6. Let's move on to part C. And in this question, we are told that for another spinning toy, the volume is 2 pi cubic inches. And again, we need to find the value of c for that spinning toy. And so let's see what the volume is. The formula formula for the volume is equal to integral from x0 to x1 of the area, which is a function of x dx. And in our case, the area, because this spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis, that's actually, this value is y as a radius, y is equal to radius, and so this is equal to integral from x0 to x1 of pi r squared is a function of x dx. And r is just y, so we can plug this in here. And we get integral from x0 to x1 by f of x squared dx. So let's just plug in the value, and we know x0 is 0, x1 is 2, and the functional form is given to us too. So our volume in our case is given to, and I take pi out of the integral from 0 to 2, and then the area is c x square root of 4 minus x squared dx, which is equal to pi c squared integral from 0 to 2 x squared 4 minus x squared dx, which is just all power functions here, so we have to be just careful not to make a simple mistake here. Pi c squared, and then integral from 0 to 2 of 4x squared minus x to the fourth power dx, which is equal to pi c squared. And then here we have 4 over 3 x cubed minus 1 over 5 x to the fifth power, plugging in values of 0 and 2. And this is equal to plugging in 0 gives 0, and plugging in 2 gives pi c squared 4 over 3 times 2 cubed minus 1 over 5, 2 to the fifth power, which is equal to, simplifying 4 times 2 to the third, 4 times 8, pi c squared, and then here 32 over 3 minus 32 over 5, which is equal to, bringing to the common denominator, this is pi c squared 5 times 32 minus 3 times 32 divided by 15, which is equal to 64 pi c squared over 15. And we know that it's given to us that this volume is equal to 2 pi. So pi cancels out, 2 and 62, we get that c squared is equal to 15 over 32. And so c is a positive constant that was given to us. C is equal to the square root of 15 over 32. And that's our final answer here. Thank you for watching. If you liked this video, please don't forget to click the like button and write me your comment in the space below, and subscribe to my channel, where you can find more solutions to the Calculus AB and Calculus BC problems. And I will see you in the next video.